So use linked list to implement. Okay. So before, like we said, we can use just a simple linked list constructor, just initialize two front and rear, right? And this could be just big of 1. And the logic is whenever you enqueue, just enqueue to the rear, create a new node, just 3 steps. Point it to a new node and move the rear, right? And that's the code look like, right? So DQ, just move the front to the next one by getting like front.next, right? Front.getLink, front equals to front.getLink. And make sure you not DQ and empty queue. So this also big of 1, NQ and DQ, they're big of 1. But we said we can upgrade that into the circle linked list, like linked list that has no ending, like a circle, like a ring. So when we reach to the end, we pretty much need a pointer to point at this is at the end, so this is the rear. Instead of pointer always point to the front, so it's always point to the end. And then whenever we say rear.getLink, it's always give you front of the queue. So that's why we no longer need front, right, pointer. Now this is measuring the efficiency here, right? So we say storage size array base takes the same amount of memory. No matter how many array slots are actually used, if you only use 10 slots and you allocate 100, it still allocate 100, right? So that's the memory storage. Link-based takes space proportional to actual size of the queue, but each of them requires more space than with array approach. So if you have 10, it's going to take 20. But it's only take 20, not take 100 if you have 10. But if you know that you're going to have 100, you should use array because it takes 100 instead of 200. Right? But if you don't know, then you better use linked list. You don't know the size. Now this comparing in terms of storage. Efficiency of the operations. So all operations for each approach are big of 1, except for the array based, right? Which the constructor will take big O of n because you have to allocate the memories according to size. I said one more thing is if you do an array of bounded queue, then you have to rely on enlarge. That will cost you ON when you do NQ. So just remember that, and then you should be fine with the test, right? This is just the full UML diagram of the implementation with interface and bounded array and linked list. Now, one thing that is very important is when you do concurrency. What's concurrency? Concurrency meaning is when you write an application and this application has to share, right, amongst different users. Like in that example, multitask. You have to perform more than one task at a time. Right. Several interacting code sequences are executed simultaneously, either through interleaving of statements by a single processor or through execution on several processors. Right. So, for example, when you if you look at Google, right? Yeah, that's a good example. Everybody just go to google.com at the same time. And what happens if millions of users happen to hit that search at the same time? That's called example of concurrency, right? And you know when you do search, what happens behind that? It's like just like I'm searching something from your list, an order list. And this I'm looking for Mr. Andrew from the same order list. You already implement order list, but 100 of user is looking at the same order list that you just implement. Then that means they're going to call the .contains method at the same time. What are you expecting that your program will behave? So that is this concept. So like for example, look at this code. I have a class named counter. Counter has the counter constructor, initialize 0, increment count ++, and string to string. Okay. I want to show you this one, right? So we have the main. Main is going to call instantiate object of that counter, call my counter. And my counter call .increment 3 times and print my counter. So what should be the value of count? Increment 3 times. This is only one program, correct? So we expect to see, because it's only one task going on here. But if you look at another one, so we said we're going to make a class named increase. This implements runnable. This is an interface, right? When we want to create like threads, we need to use this. Threads mean multitasking, many program calling at the same time, simultaneously or concurrency. So private counter C, same counter, private in amount, and we have the constructor for this as increase, path the C and amount in. So this dot C equal to C, this dot amount equals to amount. That's how you initialize it. We say we run the loop here. C dot increment. So when you create a thread, you require to have a run method. Runnable is an interface that asks you to implement run. Just like when you do compilable, you have to do compare to. Similar to that. Runnable, you have to do run. Okay, so now when you use this in the main, when you use the thread, it's required you to do throw interrupt exceptions. So we throw that. So counter C equals to new counter. We just the same counter that we looked at before. Runnable run R equals to new. Now we see that we're going to create an interface runnable, right? Because it implements runnable, which is a type of increase class. So when we pass counter and 10,000 in amount to count or increment, with the same constructor C that we initialized earlier, that is going to be 0, right? So we pass this in, and then we set thread T equals new thread R, T dot start, this is called run. Okay, when you do T dot start, this will call run. It's going to loop and do increment. Question is, what should be the output of C? Answering to this, we have to see that how many threads. So first thread is the main thread that's running this program. Second thread is the one that we start right here to loop, increment 10,000 times. Now we're seeing that which one is faster? Main thread is going to run faster. Start and then go to print. So that's why the number that you're going to print is very small, depending on the CPU speed. It could be 44, 66. It's going to print right away, while the other threads still increment and counting. So that's why if you print this, you can have a small number. Because there are two threads, right? So this is explaining it. You start the thread, and then this thread starts to count, and then you print right away from wherever it is, right? How to fix this problem? We have to use the keyword join. So we put T.join. It's going to be 10,000. join, make it wait until that second thread done, then the main thread will print. So let's look at this one then. Same, right? But now we create two runnable and T1 and T2 for threads. Start and use join, and then print count. And we pass 5,000 to each. So the question is, what should be printing out here? So looking at this program, there are three threads, right? Main thread, thread T1 and thread T2. Okay, they start at the same time, and they wait. So that means main thread will wait until T1 and T2 is done. But the problem is T1 and T2 is sharing the same resources, which is 1. It could be possible that they can call run at the same time. So what happens when they call run at the same time? Then the count may not reach 10,000. Why? Because T1 said increment to 12, T2 said, since it's the same time, then it can start that it increment the same values from 11 to 12. And then they have 13, store the value 13, right? So that's why we never reach 10,000 if it happened to call at the same time. So how do we solve this problem? Simply put the word synchronize to the increment, right, for your count. So that means it's going to make sure that if someone is using count, they will not let another one using it until this guy is done. So then we will have 10,000 out, and that's done.